also going to record the session as well. So screen two. So one thing that you'll notice, oh, there we go. One thing that you'll notice is in Blackboard, I added on the side panel, I added class Zoom recording. So if hopefully this will work, and hopefully it does work. If there's a occasion where you can't see all the Zoom meeting, or you can't attend or something along those lines, I'll make every effort to record them and then put them on. They'll be on YouTube on our class channel, and then go from there. So if you have any questions about that or anything, just let me know. But that's what I'm trying to make an effort there to make this material available to whomever needs it. Um, so that's just a little bit of an update. Another just mention, schedule wise, we're kind of in the end of week 2, beginning of week 3. So we should be staying on track in terms of the schedule. I will, if I forget, please remind me if you need it. But I wanted to mention that this week we move into factor analysis, which we'll talk a little bit about later on. We have our homework assignment that's due on Sunday, like each week. This is the factor analysis assignment. But then what we also do is we start doing the discussion questions. And if you'll remember, there's only like 4 or so discussion questions throughout the course. And these are online discussions through Blackboard. And there's a specific rubric that outlines how to when to make a post for full credit, and the details in terms of the grading. So the discussion 1 then, factor analysis, and the last time, or it ends, I guess is a better way to rephrase it, on Saturday at midnight. So the homeworks are due on Sunday at midnight. The article discussions, the 4 that we have, will finish up Saturday at midnight. Now, of course, you can always do all this stuff early in advance. You don't have to wait till the weekend. You don't have to wait. You can do this stuff ahead of time. So, but with the articles, since we hadn't done one of those yet, or one of the discussions rather, I just wanted to click on it in Blackboard and just kind of outline here. Just the DQ discussion question number 1, factor analysis. There's an article that's associated with each of the discussions. So you should click on the article, read the article, and then talk about the, kind of respond to the article based on what the discussion kind of calls for. It would be real helpful for you to have an informed discussion after you watch the videos and read the chapter and the text, because again, like this discussion deals with factor analysis, so the article has a factor analysis in it, and for you to be able to really follow the factor analysis in the article, it'd probably be helpful to read the material ahead of time and maybe watch the videos. Okay, so I think if you click on the actual discussion question, well, great. I thought, oh yeah, okay. So then if you click on the one that says create a thread, well, shoot, I thought I had the rubric on here. If not, the rubric's on the syllabus itself. So if you want to see the grading scheme, for some reason I thought that the rubric was available for you within the discussion question forum. Sorry, I thought it was there and now I'm confused, which happens often. But anyways, um, if you go to about the course and then go to the syllabus and download the syllabus, then the rubric for um, discussion questions, it's on the very last page of the syllabus. So you'll find it
Just
right.
wanted to add that the rubric is actually there, Dr. Flight.
Is it there?
It
Okay.
is, it is. Yeah. Are you in
Okay.
the student view?
And it might be that with my view of Blackboard, it may not be exactly the same as yours in terms of the, what you can click on and whatnot. So good, I'm glad. Okay, so basically there's the initial post and then there are your response posts to your classmates. Those, your initial post is 50% of the overall grade. Your response to your classmates are 30% of the overall grade. So, what we're looking for is some meaningful, discussion on your take of the article, but then also responses to your classmates. There are some deadlines based on time. So your initial deadline or your initial post for your initial thread to create an initial discussion post would be 2 days or 48 hours before the due date. So backing up from Saturday at midnight, that'd be what, Thursday at midnight, I guess. Um, and then so an initial post by Thursday at midnight, and then your response to your classmates a solid day before. And that allows time for back and forth discussion, which is kind of the goal with a discussion, back and forth. Um, but you'll notice that the actual timing components here aren't super heavy in terms of a weight on the overall grade on your discussions. Most of the weight is on what you say and what you talk about and how you respond, in terms of the content of the discussion. That's really 80% of that grade is really built into that. Okay, so if you have any questions, by all means, let me know, or if there's anything that you're not sure about in an online discussion, kind of environment. This is an opportunity, in my mind, to give give some credit or give some whatever for participation. So sometimes it's difficult to participate. Especially in online settings, we're not sitting here asking for debate online, but this is a way to have a discussion and a good way to incorporate class material. Okay, so anyways, at any rate, I wanted to mention that to get everybody just be aware that this week is our first one. So on the 20th, then that'll be due. And actually, I guess, so it was hard to space these all out. So the next one's actually on regression, going to be the following week as well. So we'll have a few of these coming up here before the midterm. Okay, let me know if you have any questions. All right, otherwise that'll be good. So what we'll do tonight, if it's good with you guys, is I want to spend, there's actually two parts to tonight's time together. One part we'll walk through the homework assignment and we'll look at some of the different components of um, assessing data before you start analyzing it. So part one of tonight will be like this last week's assignment and a review and just talk about kind of, walk through the examples and stuff. Part two will be more forward focused and we'll walk through some of the ideas associated with factor analysis. So, the design of the course is such that you should be able to pick up these ideas and concepts and test them through the textbook and the videos. But to be realistic, it helps just to walk through some examples, not that we're face to face, but kind of in a live setting. And I'll try not to make it too boring, but I happen to like enjoy doing a lot of data analysis. So for me, it's fun to talk about, but I know it might not be fun to listen to. So let me know if you have any questions though, and we'll kind of go from there. Does that sound okay? Sound like an okay plan? Okay, very good. Um, all right, so let me, and trust me, I have to review and refer to my notes fairly frequently. Some of this stuff I do all the time. Some of these other methods I don't do very often, but still, it helps to kind of, if I follow notes, it's actually really beneficial. So first thing we'll do is probably just talk about this survey a little bit from the homework assignment. So basically with the homework assignment, you had the survey and then you had an Excel file. And one of the elements of this first assignment is really the idea of managing data and being able to kind of see where the data came from, um, maybe connect the actual spreadsheet to the questions that were asked so that as a researcher, you're kind of familiar with where the data is coming from and how it was obtained. I actually think that's a really important thing to be able to do because it helps you understand the intricacies of the data a little bit and the anomalies of the data a little bit better. Um, the other aspect of this is the more data management you do, kind of the more you pick up on little mistakes or little challenges that the data may have embedded in it. So that's just kind of the reality of it sometimes, a lot of times actually, especially if you're doing new research, a lot of times that data may be um, contaminated or it may have issues in it that you have to overcome as a researcher, but you don't really know until you really get into it and start doing the dirty work. So being able to take the data and look at it in Excel, being able to code and label each variable appropriately is just, a good habit to get into because it helps you better understand your data going in. So anyways, the data is here, or the survey is here. This is a survey that was initially done. It was actually sponsored by by Porsche USA. And they wanted to better understand kind of the emotional connection and emotional tie-ins consumers had with brands of cars, and their initial focus was on luxury brands. But as the survey went out, that luxury wasn't kind of the only thing that was done, that was really focused on, or measured or captured. And then a second follow-up data collection was done to incorporate some ideas of aspirational brands. So like maybe today I own a Chevy Cruze, but someday, in the future when I, get a few raises, maybe I want to buy, I don't know, something nicer, whatever that nicer car would be in my mind, in my perception. So it's kind of like, what do I aspire to own down the road? So that's kind of hard to capture, and I'm not really sure that this data set does capture that, but that was the idea. So the earlier questions sort of warm up the respondents by asking them some easy questions that should be really easy to answer, that shouldn't be really very subjective. They should be very just kind of like, they are what they are. So like asking what type of car they drive today, a sedan, a sports car, a coupe, a minivan, whatever. That should be fairly easy to answer. And you'll notice that in the survey, the numbers on the side here indicate how that item is coded in the data set. So if somebody on this variable, if you look at the Excel spreadsheet and you see a 2 there, it means that that person owns a coupe. So that's the coding part, being able to transfer the intent of the question from the verbal sense of the survey to the numeric sense of the spreadsheet. is linked by the coding and coding scheme that's used. So as a researcher, it's, you know, if you want to know what the numbers are 1 through 12, you have to have the survey and you have to have the coding sheet to know what any of it means. Moving on, we look at select from the drop-down menu the year. Now, some of you didn't notice this at all. Some of you did notice that there are some problems here. So when you did your frequencies and you did, you know, just kind of some of your data analysis, you might have picked up on this, or when you read the survey, you might have picked up on this. And basically the deal is in 2012, the data was collected initially, and then a supplemental data collection took place where in years after 2017. The problem is that the original Qualtrics survey was set up 1 through 84, but we had to also add the years 13 through 17 to accommodate the new data collection. Problematically, 1930 and 1980 and 2017 were both coded the exact same way. They were both coded as 84s. Now, it's probably not that big a deal because there aren't that many cars that were, I don't know that there are any 1930s in the data set. So in other words, there's probably not anybody who has a 1930 car. And if there is, though, it would also indicate that they have a 2017 car as well. So, you know, seeing that this is a problem, you know, you probably manually have to go through the data, find all the 1984s and kind of see what kind of car was there. And if it was like a Model T or something like that, then you'd know it wasn't a modern car, wasn't one from 2017, or you'd have to make some type of a judgment call as to what to do with that data. It's not like the biggest problem in the world. I mean, if it could be, of course, if the duplicate numbers were real popular, you know, years, but this is probably not like a real big issue to deal with. But it's something that as a researcher, you would need to know and kind of pick up on, or it'd be nice to know anyways. Okay, other questions then. So what year the vehicle that that you feel some attachment to, choose up to 3 brands. So you can choose up to 3 brands. Now in the data set, I've got to remember, you know, you're probably going to have 3 columns, and each column will be for the, you know, attachment 1, attachment 2, attachment 3. Just because you're choosing 3 brands here doesn't mean that they're in order. Like choosing like attachment 1 on the data set doesn't mean that's your first attachment or your most favorite. It just means it's one of the 3, right? So, you know, some people only chose 2, some people only chose 1. You know, we didn't require people to choose 3. There's probably missing a lot because, you know, they only chose 2 instead of 3. So again, how this is interpreted as a researcher and what matters, you know, it's kind of in the questioning. And it may mean also, as you look at the data more, that it was a bad or poorly worded question too. I mean, there might have been, you know, ways we could have rephrased that question in a better way. Having seen the data, we see it now, but at the time when we wrote the survey, we really didn't. You know, could we have asked them to order preference these, like most attached, second most attached, third most attached? Probably. That would have also possibly been confusing, and it might have been hard mentally for the respondents to do it. So anyways, there's, you know, maybe pros and cons in terms of how to ask that. And quite frankly, at this point, I'm not really sure how good the question is and how much use we can make of it. But I don't know, maybe we could do something with it. Next, choose the brand that is your dream vehicle. So this would be your aspirational brand. Do you guys remember what the most frequent brand was? Anybody?
It was Jeep, I think.
Yeah, it was Jeep, which I still don't understand.
Yeah, I found that funny too.
Go figure. I do not know why. I mean, I think that I can't remember, but I think the sample was probably maybe really young adults. So maybe for a young adult, maybe that I don't know, Jeep for whatever reason. I don't know. I was picking, like BMW and Bentley and I don't know. But anyways, so we here choose only one brand here for them to reflect on or to think about. They don't have to have owned the brand, but they just have to think of it as a brand they would like to have as a dream vehicle down the road. Okay, and then we asked just a whole bunch of questions. And the way this is in Qualtrics is we piped in their response. So whatever they responded to as their dream vehicle, it appeared in their survey based on whatever they checked up above. And so that's these kind of weird looking inserts here is the piped in response that they made. So that's kind of a nice way, if you've never done that before in Qualtrics, to make a unique type of a thing based on people's responses, based on consumer responses. Yeah, okay, so yeah, we have a bunch of questions. These are all 5-point scale questions, like or like. So they're going to be, we'll convert them. They'll be metric, but at the end of the day, or interval scales really is what they are. But we'll probably average a bunch of these together. Okay, again, bunch of questions, dream vehicle questions. Yep, dream vehicle questions. Switching behaviors, all kinds of stuff we're asking. Question 7. So you probably recognize this as a Net Promoter Score question, NPS. It's a pretty common thing that people ask, and there are deviations to this. But basically, the nut in a nutshell, it's like, how likely are you to recommend this product or this brand to your friends and family? It's basically the question. It's the likelihood to recommend question. In industry and just kind of all around, it's been dubbed or called the Net Promoter Score, the NPS. So we should be able to create or calculate what's called the Net Promoter Score. And it's where you take the difference between the percentage of respondents who promote the product less the percentage of the respondents who are what we call detractors, or people who don't promote the product. So in practice, the way this works is you take the percentage of people who clicked on 9 or 10, and we call those people the promoters. And we take the people who clicked on 1 through or 0 through 6, and we call them the detractors. And we take those two percentages, take the difference, and that's the Net Promoter Score. So in practice, this is actually something that is done, and that's where this question kind of originated from. Okay, makes sense? All right. Now, I might as well mention it now. There's a variable in the data set called promo group. So if we pulled up the actual data set, made it a little bit bigger so we can see, came down along here, and we did promo group right here. So this, you wouldn't know this normally, but you would notice that it's here, and you should ask about it and wonder why it's there. But again, you wouldn't maybe normally pull this together, especially if you didn't know what the NPS was. But it's just a simple grouping variable. So anybody who's a 9 or a 10 in Net Promoter Score is in the promoter group, which is group 3. Anybody who checked 7 or 8 is in the middle. They're called neutral, so they're 2s. And then anybody who did a 0 through 6, here's a 6, is a detractor. So they're in group 1. So what we would do is we take the percentage of group 3s minus the percentage of group 1s, and then we'd have the net promoter score. But that's, again, this variable here, so it's not uncommon where you may create variables and you may use the data that you have to create new variables. And that's simply what this one was. And there is not a direct question on the survey for it. It was created. It's a new variable that was an artifact of the net promoter score. Okay, so that's where that. So I know everybody kind of asked that, or a lot of folks asked kind of what was going on with that, and that's what that is. Some other questions. This is a weird question. This question 8.1. This doesn't really have anything to do with the survey, with buying cars so much. This is a compulsive buying inventory, or a compulsive buying scale. And it's just like a consumer behavior type thing. This was thrown in there for an academic reason more than anything else. It doesn't really have a lot to do with loyalty necessarily or anything else, except that it's an interesting construct sometimes to measure. And so anyways, that's why that was in there. And then we have our demographic variables. So those should be fairly straightforward in terms of what's there. Okay, so that's the survey. Just walking through and kind of, if you have the spreadsheet and you're kind of reading through the survey and you're looking at the spreadsheet kind of side by side, that's usually a good way to kind of do that. Just kind of making sure that what's in the data set appears to be reasonable with what's on the survey and that things line up properly. That's usually what I do. A lot of times I'll take the data in Excel and I'll start looking for like big areas where I see gaps. I'll do a little bit of that. I certainly label my variables based on things that I think make sense or that I feel are kind of planned within the data. So this particular data set, again, we're talking about the current year, current type, and current brand and loyalty of my current car. These attached scores are the 3 vehicles that people might have put, clicking 1, 2, 3. And I think the way it should be is these all go up in value. So 13, 16, 19, 7, 14, 44. So in other words, the software just picked the choices in order, and the orders was all in numeric order. So if you looked at your data and you noticed that each response was higher than the other one, then that would have been it. Again, there's no order implied here. These are this is nominal data. So these are just brands in no order whatsoever. It's not 1, 2, 3. It's just brand, A, B, C or whatever. My dream brand, identity signaling is a variable, or it's an idea where you buy a brand that reflects your identity. And so these are questions that relate to identity signaling. We'll talk about those a little later when we do factor analysis. And so each of these, again, they're just ordered, or they're kind of put together here where they kind of go with each other. Social recognition, like this brand brings me social recognition among my friends. This brand boosts my self-esteem. With this brand, I have emotional attachment. So there's actually a couple different dimensions of emotional detachment. Intentions to buy, word of mouth, switching rates with competitors, satisfaction, and so on. And here's our compulsive buying scale. So we had like 8 or 9, eight different compulsive buying questions there. Okay, so again, the data is organized really kind of the way the survey is, but it's also organized by key constructs that we're trying to measure here as a result of kind of this type of research.
Dr. Flight,
Atul, yeah,
I just had a question.
sure.
Could you just go back to the survey, please? For the current year question, I also noticed that there was in the coding, so there were 2 1s, I think for the
Oh.
year 2012, and I do not drive. Yeah, so like how would
Oh,
you
that's a big
go
problem.
about resolving that?
So the thing about it is as a researcher, you kind of need to just think about how you want to deal with that. If they don't drive a car, then they should not have responded to the earlier questions.
Mm-hmm.
So that's one thing. So before this questions, I don't drive or I don't currently have a vehicle to drive. These other questions that preceded it, or this question would have this number 12 checked, and
Yeah,
then the following question would have this number, would be labeled number 49 checked. So
yeah,
you could cross-reference those.
but it still didn't match.
Still doesn't match.
Yeah, it still didn't match. So I thought that was odd as well.
That's a
There are
problem.
some people who had selected that they didn't have a car in earlier questions, but then in that particular question, they selected a year. So I was like, okay, you're not meant to have a car. Why are you selected
So,
a year?
the reality is, the true reality is that you have to decide as a researcher what you want to do with that. Do you just want to throw out 2012, or do you want to just assume that that it was just a mistake or something along the line? I don't know how many numbers we're dealing with, like whether it's a large number
I
or
think it
not.
was maybe like actually, I don't know. I can't remember, to be honest. But
Yeah.
it wasn't too large.
Yeah, it's still problematic.
Yeah.
What a
Okay.
pain in the neck. Whoever coded this wasn't thinking.
All right.
Dr. Fleck,
uh,
I had a question too.
yeah.
Usually when you look at a survey and then you look at the data, is it always or is it most of the times every question matches up in the exact same order in the data? Because
Yeah.
if you, I mean, those titles really don't say much with the question. So with knowing if it's the right data versus the right question, that's how I was.
So that's a very good question, and it's very helpful to kind of have some of the back history on it so that you can confirm that the data lines up with the appropriate questions. So the answer is no. The answer is yes and no. So if you're running like Qualtrics and you do a survey, when you download the survey, the data will align with the questions in the order that they're asked. But once you download the data, you may choose to move data around, like move columns around. I mean, there's no reason why I can't take these compulsive buying questions and move them in my data set somewhere else if I wanted to, if I just wanted to replace them somewhere else in the data set. So sometimes, like if I'm asking questions, like so these questions all relate to compulsive buying. Sometimes what I'll do is I'll spread questions out throughout the survey so that the respondent doesn't get too comfortable with one type of question. So like the respondent might answer the first 2 or 3 of these CBT questions, and then they may kind of get burned out a little bit, or they might just answer the rest of them just in a real sloppy way, assuming they're all the same. So I don't know, every once in a while I'll spread questions out, even though they all kind of go on to the same construct. And so once the survey is done and I download the data, I'll take those questions and I'll reassemble the data so that they're close to each other for analysis. I don't know if that makes sense or not, but it just happens with this survey that I think the survey aligns pretty well with the questions, if I remember correctly.
Yeah, I mean, I kind of just went with thinking just the way it aligns, you know?
Yeah, the
I mean,
other,
I took it that way. I didn't
so
do it.
the other underlying element that you're mentioning too is that, like, as the survey designer, I had a purpose and I had an intent for every single question, and I kind of knew what these questions all were, all that what they were all for, like emotional attachment. I mean, I kind of, I knew I got a scale. I've used a scale before. I knew what all these questions were, and somebody who's just picking up the data set really wouldn't know that at all. They would just know that they're labeled like this, and they might not know the back history of it at all. And so so actually, I mean, having this Excel sheet done the way it is, it should be in such a way that somebody who's never seen it before can pick it up and sort of interpret it pretty quickly. I mean, that was the hope anyways. Yeah.
Okay.
Great question though. That's a good, kind of a good thing to be asking about. Yeah. Yeah, this data set, we still haven't used it for much, so I don't know if we're going to or not. It's sitting here, and it's a good size, 459 respondents, 458 respondents. So anyways, so question number, let's see, we had question number one. Or not question number one, but taking the data and then put it into Excel and kind of that whole process. It's all part of kind of a data management thing. Now, again, there's a good amount of work to do with this specific data set because it's new data. Like if we were doing a panel or if we were doing reoccurring analysis where we had the same data coming in once a month or once a quarter, once a week, then a lot of this work wouldn't have to be redone every time. It's just collected. If it's project data though, and you're doing this as a specific project, then this work is probably going to need to be done in a lot of detail, probably at least once or twice. Okay. All right, so let's assume that we have the data there and we've looked at the survey. And then what we can do is we can start looking at it in SPSS. So I have here the data file, and it should be the full data set. Yep, 458 respondents. And these are all, this looks like all the data that was there. And if we go into variable view, there's 54 variables if you include the ID at the beginning, so 53 otherwise. And one of the things that you want to do is, and then this is up to you really. Like I personally am a fan of using a name that actually kind of indicates what the variable's about. You don't have to. You can just do variable 1 through 53 and V1, V2, V3, and so forth. To me, that's a little bit cumbersome because I really like to kind of have a better idea of what V2 means or V6 means or whatever. So I tend to give a pretty descriptive name, but again, that's kind of up to you. If you have a code book and you have it written down somewhere what each one means, that's great. Being able to define, you should be able to define what type of, whether it's a numeric variable or, kind of what it is. That's pretty straightforward generally. yeah, we have all numbers here. We don't have any qualitative data really, or open-ended questions to speak of. Width, decimals, that's pretty self-explanatory. The label, so the label here is the actual question that was asked. It's not 100% complete, but it more or less is. Again, this would be drawn from Qualtrics. If you download your data directly into SPSS from Qualtrics, it'll populate all of these fields, a lot of these fields for you, not all of them, but a lot of them. So that's sometimes helpful to do as opposed to importing through Excel or something like that. Values. So again, this is real helpful to do. You don't have to, it's more of a labeling thing, but it's helpful to do. If we have, you know, what all these values specifically mean, then that's good. You know, for each of these categories, that's kind of, that's helpful. If you remember the promo group variable that was created, this is the net promoter score group ID. And again, this is not something that you would necessarily know. You'd have to deduce it. And, you know, I'm not, you know, that would take a little bit of just, you know, kind of digging in and figuring things out and being a detective. But detractors, neutral, and promoters are those guys, and so forth. The other big area that you want to focus on, of course, is the measurement type. So being very, very specific in terms of specifying nominal data versus scale data in particular is what we want to focus on here. Well, that's not a good one because it's, yeah. We don't have a option for interval, but that's okay. It would just be scale, whether it's interval or ratio. Otherwise, otherwise nominal or ordinal is kind of where you want to go with that. Okay, but that should be fairly straightforward. Any questions on that data prep?
Dr. Fly, speaking about the scales, I was a bit confused. Okay, not that I was confused, but I know sometimes like Likert scales are seen as interval,
yeah,
ordinal, right? So I was confused, like I didn't know which one it was, because even though there's like a logical order, there's no specific like difference between each option.
So that's a fantastic question. I will tell, I haven't mentioned this to you guys, you folks yet, but I should tell you that I am absolutely not a mathematician. So math theory is not something that I would even be equipped to talk about really, really well. Except, you know, we look at this idea of scales, and you know, the definition of an interval scale is that you have equal distance between options. It's not that just one option is greater than the next, which is greater than the next, which is greater than the next. They, you know, we have order and successive order, but interval also means that the space between our options is equal. So in other words, if I have a scale that's like, it's a Likert scale, it's a 5-point scale that goes from agree to disagree. If I just have that there in 5 little spots, then the question is, well, is it really interval? However, if you put numbers like 1, 2, 3, 4, 5, you know, and label those options with 1 being agree, 5 being disagree, and you label them 1, 2, 3, 4, 5, well, then it is interval because there's a numerically equal distance between each of the options. It's, you know what I'm saying? So it's like when you think about that definition of ordinal versus interval, I think a lot of it comes down to how you labeled those options. If they're labeled in intervals, distance, in equal distances, then it's interval. Now, the problem is, or the deal is, I think with a Likert-like scale, it's always implied that there's equal distance between each one of those choices from 1 to 5, or, those spaces that are there. So, if we go back again to the scale here, we've got like this one here in particular. Oh, that didn't work. That was just silly. Hold on. We'll just do this. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a 9-point scale labeled numerically with equal distance between each choice. So that's clearly an interval scale. There's not a 0 or a true 0 point here. So it's not a ratio scale. So in other words, like I could equally put 10, 20, 30, 40, 50, 60, 70, 80, and 90, and it would still be the same scale. It would still be an interval scale. So it's not a ratio scale, but there's clearly equal distance between each of these points. If I go to one of these Likert-like scales down below here, the question is, if we didn't have the 1, 2, 3, 4, or 5, the question is strongly disagree, is the distance between each of these equal? And I think you assume yes, if it's a Likert-like scale. I mean, I think the assumption is yes. And, the reality also is that if it's an interval scale, you can take the mean of it, you can do the standard deviations, you can treat it like continuous data, you can treat it like metric data, so you can do regressions. I mean, if it's ordinal, then you can't do any of that if it's ordinal data. So as a researcher, you definitely want to make sure your scales are metric if you want to do that type of analysis on it.
Okay.
Fantastic question. And again, I'm not like, I can't give you the math theory behind it. Like, I have an older brother who's a mathematician, and he could. I can't
think
at all.
Here thinks that they are ordinal. I think so. I think I remember him saying that when we had him earlier in the year. If the questions don't explicitly state, like the numbers, then he said to take it as ordinal.
Who was that? Was that Dr. Hare?
Yeah.
Yeah. Yeah, and I think that's true. I think you just want to be careful that there's, I've even done this where I've measured the actual distance between dots to make sure they're equally distanced. That's a little excessive probably, but I've actually done that just so that even the implication was that there was equal distance between them and that they weren't shifted one way or the other. The other thing that I'll throw out there just to think about, and I don't know this I think I do know this, but I don't think it's been proven, but I think if you use really short scales, they behave like ordinal data, and less like interval or metric data. So in other words, a 5-point scale, it's pretty limited in terms of how many options. The implication is that once you move into metric data, the data should be continuous. It should be continuous data. And you should be able to treat it like a continuum, like an infinite number of options. And if you only have 5, well, that's not infinite for sure. And I think the shorter the scale, I think the more trouble you get into when you start thinking about like variability, like how much variability is in the data. Variables are supposed to vary. And if you've only got 5 choices, how much variability could there really be in 5 choices? Now, if you had a slider scale that people could slide and the options ranged from 0 to 100, now all of a sudden you've got 100 different points that they could fall on as opposed to just 5. And you're going to get a lot more data, a lot more specificity out of that scale. It's far more continuous than a 5-point scale. So, I mean, that's a little bit beyond kind of where we, you know, again, that's kind of more in the math theory stuff that's out of my league, but I'm beginning to use fewer and fewer 5-point scales, you know, for sliders and for some other, you know, ways to get people to give me more variability in their responses. I'm not 100% sure that's right, but I think it is. So, I don't know.
Okay, thank you.
Yeah, no problem. So this should be the data set anyways. This is more or less kind of where it is. As you're doing this this assignment, as I'm looking through my notes, one of the first questions is just simply asked to describe the data and kind of give some summary statistics, just a basic, you know, kind of like what the data is. I think it was actually question 3 that might have, I know a lot of folks did a chart that just, you know, kind of described the data. So under analyze, if the data is nominal or ordinal, then you would look at frequencies, right? You're never, ever going to take the mean or find the standard deviation or any of that for nominal data, ever. So if I ask somebody's anything, any of these things that are nominal or ordinal, we're going to describe them by their frequency or percent frequency, right? So just, I know there were a couple folks who took the mean of these items, and you know you can't do that. It just doesn't make sense to do that. So these guys here, we wouldn't do those at all. No central tendency, no dispersions for nominal data or ordinal data. So again, looking at kind of this, each variable, like how often each variable or each option appeared by variable is a way we would describe this. Wow, we had 67 2012s, so that is a good number, 2012s, which means that they could have also been people who didn't respond or didn't have a car either. All right, well, as a researcher, that's a problem. But again, you know, just kind of walking through this, describing how many vehicles or what it is. Percents are always good to look at. A lot of Chevys, a lot of Fords popping up here. We have folks who had connections. You know what? One thing that might happen or you might do is consolidate, attach 1, 2, and 3. Again, this is beyond the homework assignment. But if I'm a researcher, what I'm probably going to do is I'll probably combine those 3 questions to get total counts. They can't answer the same brand twice. So it's not like there's going to be one person who does Ford 3 times or anything like that. But it might be nice just to consolidate all 3 of these to get a total count for these questions. And then you could get a pretty good thing. So in other words, there were 21 Acuras here. Oh, there weren't any there. And then, well, maybe that wouldn't, yeah, that should work. Audi, 73 Audis plus another 3. So there'd be 76 Audis total. So I'd probably do something like that to combine those 3 together. And then I'd start dealing with it later on. Here's the dream vehicle question we spoke of earlier. Jeep, 8.7% of the respondents thought that Jeep was their dream vehicle brand. Lamborghini, Land Rover are up there. Audis are up there for sure. That seems to be like the top few. Mercedes are up there. Lexus. So that's pretty predictable. I mean, that would sort of make sense. Cadillacs, of course, are up there as well. Okay, so that kind of makes sense. Oh, net promoter score, IDs. So what you do is you, you know, if you would probably break this out by brand, because this is like the entire sample. So it's like the entire sample doesn't really make sense because this is typically a brand or product level measure. But like I would take all the people who had Fords and I would take the promoters minus the detractors to get the net promoter score. So as an illustration, again, if this was for a specific brand, we'd take 33.1% minus 27.7%, and that would be the net promoter score. That's how you'd use that. Okay, but anyways, you get the point. This is descriptive statistics. This is just kind of how we do this. If we're going to look at, if we can look at these variables. Oops, I don't know what happened. Analyze. Where's my, huh? I don't know where my little dialog box went. Oh, I know where it went. Sorry. I have two screens. All right, so so for you know, for interval data or our scaled data here, then we would, you know, we would bring these over, and I'm not gonna bring them all over right now. There's not really. For descriptives, we can also do this under Explore. There are a couple other ways we can do this. So you can just, you know, run descriptives this way and start taking a look at how these things look. Again, I only did a few of these. I didn't do all of them, just for simplicity reasons here. We know that these are 1 to 5 point scales that we've pulled over. We have the mean, standard deviation, so we have some other moment skewness and kurtosis as well. Okay, so so again, this is kind of a good way. You can do some histograms on this. You can do some other things as well. As we're doing this, I'll just, you probably have used Explore. And again, I tell you what, I'm not gonna use all of these variables because there's just a ton of them over there. So we're gonna just do a few of them. We look at the statistics. We can check outliers if you want, and it will look at respondents who lie outside. I believe this calculates 2.5 standard deviations from the mean. It's either 2 or 2.5 is the default for SPSS, but that's something that we can do. We can look at histograms. We can check for normality tests as well. I'm kind of hitting all kinds of things all over the board at this time, but continue. But again, this is ways to describe the data. My computer's super slow. There we go. So we have how many cases we have. We have some missing data information. Then we have descriptives. So the same information before with skewness and kurtosis, and then our standard deviations and means, which we, you know, may want to be kind of keyed in on. It's going to give us that type of information. Extreme values. Okay, so here's a good example of looking at outliers in scaled data. And this is another example of the problems with a 5-point scale and how you lack variability. So like if you look at extreme values in a 5-point scale, it's going to pull up people who picked a 5 and people who picked a 1, but that's pretty tough to say that that's an extreme respondent, you know, who's choosing. When you only have 5 options and they pick a 1 or a 5, it's just not very realistic to say that they would be outliers because they chose 1. So again, more evidence that a short scale really is not, from a data perspective, may be kind of a challenge. And then we've got normality, tests of normality. We'll talk about this. We may talk about this here in a little bit because that's one of the things that we check for when we look at individual data. Now I mentioned, I think in one of the posts, not to get too animated or worked up if your data isn't all normally distributed. Again, 5-point scales don't give you a lot of variability. And in this case, in case we don't talk about it later on, when you look at tests of normality, the KS test and the Shapiro-Wilk tests are reported here. The Shapiro-Wilk test is viewed as a better test. It's more preferred in terms of reporting. And when you interpret this, it is the opposite of what you might suspect in a significance test. So in this case, what we're looking for is a larger number. We normally have something like a 0.05 cutoff for significance levels. So in these two columns, significance, we got 0.000. Well, this indicates that each of these variables behave non-normally. These are not normally distributed data. But again, there's a whole bunch of reasons why that might be the case. I mean, look at that one right there. That's skewed negatively, right? I mean, there's a big skew on that one. Another big skew on that one. Again, short scales do this to you. So those are not going to be normally distributed. All of these are skewed in one way or another, or for whatever reason, not normally distributed. Okay, so, but the yeah.
I had a question.
Sure.
I mean, when you selected the pairwise and excluded the listwise, could you explain the difference between the two? I just never, because I tried to run both of it and I couldn't figure out the difference. I mean, what difference does it have? One of the videos you said to select pairwise when you are, but I just couldn't figure what reason is.
Yeah, so I may have to get back to you on the best answer for that, just because I'm drawing, I shouldn't be drawing a blank at all. Pairwise, I'll walk through this and I'll remember. So when you do listwise, pairwise, yeah, I actually clicked the wrong thing, didn't I? I had this otherwise differently. Bear with me just a second.
Mm-hmm.
So with pairwise, a respondent will be dropped from the analysis. So in other words, if a respondent misses the item, it's missing data, right? It's how you deal with missing data. And if you choose pairwise, the respondent is dropped from that one variable.
Okay.
But if you choose listwise, the variable is dropped. And I'm going to have to go back and double check that and confirm that, but I'm almost certain that's the distinction between the two. So in other words, with listwise deletion, you lose more data, and pairwise deletion, you lose less data when you deal with the missing item. Now, what you could do, and this is an imputation method, is you could replace the missing data with the mean. So I do this depending on what it is from time to time. Oh, that's not an option. Oh, well, that is not an option. Okay, another way you can do this is actually you can input a mean for that variable and have that inputted where there's missing data. So there would be a magical number that appeared even though the respondent didn't give it, and it would be the mean. But if again, I'll have to double check, and I shouldn't draw a blank on it, but it's something that doesn't come up too often, but from time to time. If I remember correctly, pairwise deletion is when you think of taking a respondent only out of a variable for analysis as opposed to the whole variable. But again, let me double check on that if that's okay.
Okay, yeah, thank you.
Yeah, that'd be a good thing to do. So anyways, back to the, so just quickly back to the homework assignment. After looking at the data initially, getting into SPSS, you want to think about sample size. So a couple things about sample size. You can do like a confidence interval calculation, and it's pretty straightforward. It deals with looking at how much confidence you have, your desired level of error, and the variability in the data. There's a calculation to do it, and you know, it's one of these where it doesn't really take into account the number of variables that you're measuring or your population size or anything like that. But it's something that's used. It's something that's common. I know a few of you mentioned that in your homework assignment, using the confidence interval number. And I think you had like 380 or 375 or something like that was the number that you might have used if you had a 95% confidence level, 5% error, and you used a 50-50 ratio for variability. And that's fine to do. Another method that that folks do just anecdotally is they come up with a rule of thumb or a schematic on how many respondents they should have based on how many parameters are going to be estimated. So basically the idea is for every variable that you have in your data set, you're going to estimate at least one parameter. And so what you want to do is have 5 respondents for each parameter that you're going to estimate. Okay, so this means that you have to think ahead a little bit and think about what type of analysis you might be doing. But generally speaking, again, this rule of thumb says you should have 5 respondents for each variable. But then if you split your data up and you do like between groups and things like that, then you need to multiply that by each time you split the data up. So it can get a little cumbersome, but you know, as a general rule, again, if we have 53 variables and we want at least 5 respondents for each variable, then I don't know what that was, but that's probably a good number to start with. 265. Couple caveats to this rule, though, I want you to think about is, again, like, say I have those 53 variables. Let's say, just for argument's sake, I want to compare young adults to older adults. So I split my data up between 2 groups. I have young adults and I have older adults, and I want to compare those two. Well, now I've doubled it. So I've split my data once, so I've got to double that. So now I need 530 respondents. So the challenge is you jump very quickly into like these numbers once you start doing some intricate, you know, types of analysis. Now, I caution about that because there's absolutely no way I'm going to do an analysis simultaneously using all 53 variables. I'm just not going to. I mean, there's no way I would do like a regression with 53 variables or anything like that. That's just nuts. The other thing is, if you look at this data set, you'll notice that there are some variables that go together. So like just on the screen right here, we've got this ID signaling 1, 2, 3, 4. What I'll probably end up doing is taking those 4 variables and consolidating them. And if everything is measured correctly, what I'll probably do is maybe take an average and form a composite variable. So I have just one number that represents ID signaling for each respondent. So in other words, I'm going to take these 4 variables and I'm probably going to average them together so that it's only going to be one variable that I'm actually using in my analysis. So this is called data reduction, and it's actually done fairly often, especially if you have psychometric measures that are hard to measure, where you get feelings and emotions and stuff like personality. If you're measuring stuff like that, you usually have to ask a bunch of questions to get to it. But when you start to analyze it, these 4 questions all of a sudden just become one data point. And so again, I'm not measuring all of my data. I'm not using all of my data, like 53 variables. I'm consolidating some of it and I'm not using some of it. So, I mean, it might be that I'm actually using 15 variables at the most in one analysis. I mean, if I'm doing structural equation modeling, I might use more. But still, at the end of the day, I probably don't have to. So sample size is one of those things where you need a sufficient number, but you don't need to kill yourself. You don't need thousands ever of respondents. I mean, unless you're really, really micro managing and doing lots and lots of splits. So sample size, we have the 400 and whatever, we have a pretty good size sample. The other thing that I would caution you about just in your notes is that if you have a large enough sample, it's really, really helpful to set aside some of the data and run your analysis on a sample of your sample. So in other words, if I had 500 respondents, what I might do is I might create some models using like maybe 150 of them, just randomly selected, or something along those lines. So a lot of times what we'll do is we'll take a sample of our respondents, do some data work, come up with a model, and then we'll test our model with the rest of the sample. So in other words, it's like a holdout sample that you're actually doing. I mean, if you don't do that, then the other option is to actually simulate data, which is something you could do as well. You could create a new data set that's simulated based on the characteristics of the data that you collected. But if you've got original data, again, a lot of times it's not a bad idea to do a holdout sample and create your models and then test them later on down the road. I mean, yeah, good sample sizes are always helpful for sure. All right, so that was sample size. Outliers, that was a question that we had. Okay, so again, with outliers, here's the idea. We want to be able to identify respondents who are characteristically different from the norm. Basically, that's what we're looking at. We're looking at individuals who are consistently and predictably unlike a great majority of your respondents. And the effect that they have is that they will maybe weigh your results in one direction or another, kind of unnecessarily. So they'll add a weight to your data and pull your data in certain directions that maybe is not realistic. So it is helpful to kind of identify them. Now, an argument could be made that for every outlier that is excessively high, there's another outlier who's excessively low, and they cancel each other out. There is that as well. Sometimes outliers could simply cancel out the effects of each other. So that might be there too. So outliers, yeah, you want to look for them. You want to, if you can find some that are truly abnormal respondents, it's probably some error that's going to be piled into your data that you're not going to want. So you probably try to take them out if you can. There's basically two or three different ways we look at this. First of all, would be kind of a univariate method, and we already looked at that a little bit when we looked at this data here as an example, where we clicked in Explore, we looked at or in descriptives or Explore, we clicked the button that said outlier, and we looked at, and it pulled for us these what they call extreme values. Now again, on a 5-point scale, this is going to be almost meaningless in terms of what an extreme value is. If you have a big scale, or if you have truly continuous data, if you had something like age and you had ranges from 5 years old to 100 years old, you know, there's going to be some outliers because there's a lot of variability, a lot of distance and range that's built into that scale. These 5-point scales, they just don't work that way. They're just not good for picking up individual outliers on an individual variable basis. So the way this works though, so these again, they're typically measured by a standard deviation. So like what we do is, under descriptives, we know what the mean is, and we know what the standard deviation is. So the mean here on this one question is 4.02. Standard deviation is 1.005. So this is a plus or minus thing. So it would basically be anybody who scored above or gave us an answer above 5.0205, I guess, they would be considered an outlier. Now, again, we only have a 5-point scale, so you're not going to have any, I mean, it just doesn't work because the scale doesn't go high enough. But the upper bound would be the mean plus the standard deviation. The lower bound would be the mean minus the standard deviation. And actually, I think the norm is if you use 2 standard deviations, not just 1. So this would actually be 2.01 standard, you know, instead of 1.005. So if it's 2 standard deviations, you're talking about somebody who gave an answer above 6 or below 2 or something like that. And they would be considered outliers. So this is one method of looking at outliers, simply looking from a variable by variable perspective and calculating, again, the upper and lower bound, and then identifying anybody who gave an answer above or below those thresholds. Second way that people look at outliers is a bivariate method, where we look at 2 variables together. Oftentimes we'll do like a histogram maybe, and we'll look at, like, or scatter plot rather, a scatter plot with 2 variables, and we'll look for scatterings that are out of the norm, like way outside the typical grouping. And then we'll look individually at those, and you can even do a confidence interval and say, well, look, anybody who's outside of this area or region between these 2 variables, you can look at. Again, these 5-point scales are kind of silly to do. This is so under chart graphs, under chart building, do a scatter plot. I don't know, I think we had, how loyalty was a bigger one. It was not a 5-point scale, and the net promoter scale, that's a 10-point scale. Even still, I'm not sure that we're going to get anything too fantastic. Yeah, we don't, you just get all this craziness going on here. It doesn't really tell us anything because the scales are they're not continuous. They're in the true sense. But that would be a bivariate type of analysis where we look at 2 variables simultaneously, and what we would look at are like respondents who are way outside a scattering of what we would normally expect. The third way to do this is by looking at a system of variables together and trying to identify individuals who fall like in a multi-variable sense way outside the norm. So like think about if we did a regression for each individual respondent and we looked at the betas or what was returned, and we looked at their scores, and the ones who had a system of responses that were outside the norm would be flagged. And so this is actually more appropriate for this type of data. It's a bit more complicated, but it's something that you should really think about. This is what we should be doing. So to look at outliers this way, what we're going to do is we're going to create a regression, but we're going to look for a very specific statistic called the Mahalanobis D squared, or distance squared. So it's a very special measure. Again, what it'll do is it'll look at a system of variables, and it'll measure how much variability or distance there is for each individual respondent to the norm or to the average that's there. So, you know, with regression, in regression, what we're looking for is what the normal trend line would be. So these would be people who fall way outside the normal trend, and who are very distant from that. That's what this does. So the Mahalanobis distance is something you should calculate, and we'll do it real quickly here. We go to regression, and then we go to linear. Now, I've already set up some of this. Basically, what we're going to do is we're going to do a regression, but we really don't care about a whole lot going on here. The one thing we do care about, though, so we're not going to worry about this stuff here so much. We're not going to worry about plots so much. Under save, there is a little distances area here, and we're going to check Mahalanobis. And again, what we're looking at is if you could imagine a regression with the trend line, I guess it might go that way for you, and the deviations that each respondent has from the trend line, we're looking for people who deviate a large distance. Basically what it is. It's kind of where we're going with that. So Mahalanobis distance is what's going to be measured here, and that's what we want. Options, we're not going to worry about this other stuff because all we want is Mahalanobis distance. So what you do is you choose a variable as a dependent. It doesn't really matter. I mean, it may matter, but it's not that super important what it is. We're not really choosing a dependent variable to measure something or to test something. We're just doing it to get a trend. I've got here, again, it's like the likelihood to promote, I guess, the NPS score. And then we've got a bunch of, I just dumped in a bunch of our scale variables because we're doing a regression. And so we're going to use scale variables for this. The other thing that we should know is how many of these we have. And I can't remember how many, but we'll need to know this in the next step. So I'm just going to count real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think there's 17. 1, 2, 13, 14, 15. Yeah, okay. So we have 17 variables here. We'll need to know that in a minute. But what we'll do is when we run this, because I clicked this save thing, we're going to actually create a new variable. So whenever you do save in SPSS, I think, it creates a new variable. So in our data set, there's going to be a new variable called Mahalanobis, and it's going to be the D squared, the distance squared. So that's what we actually want to see. So we'll do continue, and then we're going to do OK. And this is, again, it's going to kind of create a bunch of, it's going to create it's going to do a regression, but we're really not worried about that. That's not really kind of what we're too keyed in on here. What we do want to look at is going to be our actual data set. And you'll see down here at the bottom, we've got a new variable that was created, Mahalanobis distance. And if we go to data view, we can go to the end of our data set and we'll see Mahalanobis distance. All right, so I ran this earlier, so just for my own sake. What you get, and this wouldn't normally be done like this, but I ordered it. I sorted the cases by size of Mahalanobis distance. So you'll see that the largest here is first, followed by the rest. And what we're looking at are problematic respondents who score particularly high on Mahalanobis distance. And because they score high, it means that their response is far away from the typical average of the trend line. And they may be, again, overweighting that line in one direction or the other. So, so the rule of thumb here is that you want to, you're looking at 2.5 as, again, this would be kind of like your, kind of like the number of deviations, if you will, almost, but 2.5 is the number. And we had 17 variables, right? 2.5, 17. So so there's two ways to do it. You divide the Mahalanobis distance by 17, or you use a cutoff, which is actually easier. So if I took 17, because that's how many independent variables I had, and I multiplied that by 2.5, which is, remember, like, it's kind of like the degrees of the standard deviations. It's kind of like the numbers. It's a multiplier. It's how far away from that number we want to be. It's just a rule of thumb. 42.5 is our cutoff. So 2.5 times the number of independent variables, 17, is 42.5. So any respondent above 42.5 is going to be thought of as a candidate as an outlier. And that's kind of that's what comes up here. So we have these different cases. I think it was 1 through 9. We had 9 cases in this data set. These cases here are good candidates from a system-wide view to be thought of as outliers. Now, as a researcher, you need to decide what you want to do. You could mark them and exclude them from evaluation. You could, I would never, so don't get in the habit of you don't delete data necessarily, but you may not run their data with your analysis in terms of how you handle it. You could run your analysis with them, and then you could run your analysis without them and see if they have any impact. If you have a very large or sufficiently large sample size, you may choose just to disclude them because you have plenty of sample. If you had a really, really small sample size, you'd really be concerned about dropping them maybe because they may bring your overall sample too low. You may do some further analysis and try to identify any unique characteristics about them that, maybe they were the last people to fill out the survey. Maybe they all are, fans of the same brand and they act weird. I don't know. You could do other analysis, but at least initially, that's how you deal with outliers. So there's a univariate way, just looking at specific individual variables, a bivariate method. Then this is a multivariate method by measuring Mahalanobis distance. Okay, we're cool? Got doing okay so far? Tonight's a full night, sorry. I don't think anyone's asleep yet, so all right, we're okay. So no questions, we're okay? So far, all right. Couple other parts of the homework assignment, missing data. So missing data is another big issue that, again, causes researchers concern because it's a decision point that we make, like whether we retain or whether we discard. If we have a respondent that fills out like 90% of the survey, but they skip some, do we keep them? Do we not keep them? It's kind of like, personally, I avoid dropping data when at all possible. It's very rare that I drop data or exclude respondents, unless there's a real clear systematic trend and it's obvious there's an issue or a problem. If the data suggests that that their responses is bringing in or introducing unnecessary error, then certainly it's a consideration. So missing data, though, is evaluated two ways. One, we look at how many, we look at variables, and we look at like the response rate per variable. And the rule of thumb is, well, generally speaking, it's a wide range between 5 and 15% missing data is something that you start to be concerned about. So in other words, if I have a variable that is missed 10 to 15% of the time, then I start looking and understanding and trying to rationalize why that's the case. So many of you observed that attachment 3 was had a lot of missing data in it. That one, and we kind of talked a little bit about that in the survey as to why that might be. So we can kind of rationalize why attachment 3 may not have as many responses as attachment 2 or attachment 1. And we would want to, I'm not sure I'd be willing to take that out and drop that variable. Again, earlier I mentioned I'd probably take attachment 1, 2, and 3 and probably consolidate them somehow. And because I think that'd be a better representation of the data. And also it would account for and accommodate for the idea that attachment 3 just doesn't have a lot. It has fewer or higher non-response, type of a rate. Otherwise we look at a lot of the demographic data. So if we go to the end of the survey and we look at the demographic data, a lot of times demographic data has holes in it and a lot of non-response. It's a great idea to put that at the end of your survey so that if you have respondents drop, then you're losing that and you're not losing the other stuff that you're actually measuring. A lot of times this type of data, to me, demographic data, a lot of times is nice to describe your respondents by, but not very good to predict their behavior by. I really, really believe that demographic data is just not very good data most of the time to describe behavior. I mean, it doesn't motivate the demographics oftentimes don't motivate behavior. Other things do, like loyalty and satisfaction and compulsive buying behaviors and stuff like that. Those types of things drive behavior. These don't. So if some of these variables are not answered like to a high degree, I generally don't worry about it that much. These are usually not things I keep as part of my main models anyways. Sometimes I do some between group stuff, but otherwise it's kind of is what it is. So the thing to do then is to look at our response rates per variable, and that's pretty straightforward. We already looked at some of this earlier where we looked at frequencies. So for our nominal and ordinal data, we look at our frequencies, and we usually have here like this is the education question. We have missing data, missing from the system. How much is missing out of the data set? And we have 3.7%. We have 10.7% on ethnicity. So that is that upper region. 10 to 15% is where we start to get concerned about missing data by variable. Am I concerned because it was towards the end of the survey, so people were probably getting tired, or is this a sensitive question people don't want to answer? Absolutely. So I'm not surprised by that. And I'm probably not that worried about it. If it's a key component of my research, then I need to find a better way to ask this question, probably. And at the end of the day, I'm still probably not going to drop a question just because 10% of the respondents didn't answer it. Probably still going to keep the question in there. We got 1%, 1.5%, 3.5%. So yeah, these aren't particularly large percentages that are missing. Okay, so again, that's the all right, that's missing data for those types of questions. When we start looking at variables for metric data, back to explore. Okay, we've already got some data in here, and we don't need a lot of stuff in this, but we do need to make sure we have pairwise listed. Yeah, that should be, let's just see what pops up here. Again, my computer is slow. There we go. All right, cases missing is what we're looking at. So just in the case processing summary box, cases missing, again, 1%, 1.3, and so on. You'd want to do this for all your questions. I mean, this is, again, just a sample, but it's the process of, and it's easy to do, it's quick to do. Just double check and make sure we're looking good for that. All right, that brings us up to the other part of missing data, and it's by respondent. And so early on when I do research, I have my spreadsheet here. And a lot of times what I'll do is I will start to just look for holes or patterns in missing data that might exist. This is usually just a visual type of a thing as I start. Nothing real too scientific, but again, we'll kind of pop over here. We'll notice like there's some missing data there. Clearly when you, oh, look at all that. Look at that guy right there. And then they missed the end. When you download data from your survey, the individuals who are at the end are the ones who finished the survey last, or they're the ones who never finished the survey at all. So when you first download your data, you'll typically see lots and lots and lots of missing data in this area at the end from respondents who didn't complete the survey. Now, this data was cleaned up a little bit before, so we've already taken out a lot of the missing data, a lot of the respondents who didn't respond well or whatever. So it's in pretty good shape probably. But again, just visually, you can kind of look for little holes here or there. Not real scientific, but again, if you want to do some of this before you put it into SPSS, you certainly can. So what we want to do here now is when we look at individual respondents, we're going to actually use a function called compute variable. And so this is actually, all right, so it's a little cumbersome, and I'll kind of clean this out and start anew. But you label a new variable, and when you compute a variable, you're creating a new variable in your data set, just like we did Mahalanobis distance. This is another one to do. So this is another data point that we're creating. And we created that net promoter score one earlier too. So this will be the third variable we create. But basically, we're looking at missing data, and so I'm just labeling it missing data. If you go into this functional group and go to missing value, and then if we click here on the nmiss function, and you can just double click that, what we want to do, and again, this is a little cumbersome because we have 53 variables, is we want to bring over into this function separated by a comma, each variable. And basically what is going to happen once we run this is SPSS will count how many times each respondent has missed these variables, or whoops, or it will just give us a number of how many misses are in the data set by respondent. Oops. Crap. What am I doing? There we go. I don't know. Did I just do that one? No. So again, I'm not going to do all of these because again, this is just an illustration, but you're going to get the point, kind of see how this works. If you didn't do this already, you get the idea. So we're going to put all these variables in, again, 53 of them, because we want to count how many have not been responded to. Then if we did that, click OK, we can look at the data set and no, not that one. Look at the data set and we can see that a new variable's been created. Now, the lower the number, the better, right? So the lower the number, if it's 0, it means that they didn't miss any of the variables that I just selected. The higher the number, the more concerned we are, the more concern we have. So out of the variables that we chose, if we had 15 variables and somebody missed 3 of them, or if we did all of them and we had 53 variables and somebody missed 15 of them, we get the idea that the bigger the number here, the bigger the concern is that that person has missed too much of the data. So the cutoff here is typically around 10%. So if it's a 53 item, survey, if somebody misses 5 to 6 questions, then you're probably looking at somebody who, you might consider dropping, or you might consider doing something to, in terms of, their data and their data set, so that's kind of where that goes and how that works. Yeah. There are a couple other techniques. I'm not going to really, I don't know that I'm going to go over them tonight in terms of what we call imputation. So I do want you to know that term though, and have an idea of what it is. So imputation is this idea of what we'll do with missing data. So in other words, we have missing data here. Do we choose to do nothing with it? Do we choose to replace it with something? What do we choose to do with it? And this really works with scale variables, and it doesn't so much work with nominal variables or ordinal variables. But if we have like a missing data point there, we could leave it missing, or we could put something in its place that it would be like a reasonable guess that we think could go there. So sometimes we do something called replacing with mean. So what'll happen is this column will be CBT2. The average of CBT2 will be computed, like maybe it's 3.2 or something like that. And then whatever that average is, it'll be dropped into this spot that's empty. And, it's not really the respondent's response, but it is a approximation, based on the average. If that respondent is typical and normal and like everybody else, then whatever that number is, whatever that mean is, should be relatively close to what their true answer would have been. Not perfect, I know. Another thing that we can do is when we run the regressions or do some more multivariate analysis, the software can calculate based on its typical response for a respondent like them, could put a number in for it as well. It's called a hot deck or cold deck response. That's put in there. So there's a couple different ways to deal with that. There's actually, if you go into transform, I can't find it right now. Replace missing values. There's actually a way to do this where here's a series mean by nearby points. It's like a hot case scenario, and then we have linear interpolation, which is more like a regression type of a way to impute data. So data imputation and dealing with missing data, you can drop the respondent, you can leave the respondent's space just empty, or you can choose to put data in that is a reasonable guess as to what that respondent would have put if they had not missed it themselves. Okay, so that's kind of, and again, that's a little bit more involved, but it's certainly something to consider. Okay, you guys doing okay? All right, the last thing that I wanted to mention on this homework assignment was normality. I think that will more or less wrap up kind of where we are on that assignment. So assessments of normal. So when we do multivariate analysis, there are 4 key assumptions that we have to think about. Some of them are more important than others, depending on the method that we're using. And one of those is that the data is normally distributed. So in most of these cases, this isn't 100% the case, but in a lot of these analyses, we want to make sure that our variables are normally distributed. Now, that may not be the case if we're doing like binomial regressions or logistic regressions and things like that. Some things where you have choices, they're not going to be normally distributed. But that aside, most of the time we want to make sure that the data we're now using for analysis, especially like for regression, for instance, data has to be normally distributed, or should be normally distributed anyways. It's helpful too. I'll say that another reality is that once you hit a large enough sample size, the restriction of normality subsides a little bit. So, if you have a really, really large sample size, then we can do some other things. The other thing is, if you notice that your data, your variables are not normally distributed, there are mathematical calculations called transformations that can be applied that sometimes help. So taking the log, for instance, or the exponential log of a variable, doing some different things like that, square rooting it, may help. So be aware that those are possibilities for you to use if you need to try to normalize your data, or you need to transform your data or get it into some normal type of a state. But generally speaking, when we go into this, we're gonna again we'll go here into explore. No. Options. No, maybe I'm in the wrong thing. Sorry, guys. What am I? Why am I not doing this right? Yeah, it should be right. I think I'm just missing it. Yeah, no, okay, right here. Test for normality and histogram. Okay, we're good. We looked at this earlier, right? So so if we're looking at this data, and we looked at it earlier, I just threw in a bunch of variables there. Now, obviously, if we're looking at normality, we're looking at scale variables. We're not looking at nominal variables, right, or ordinal variables. Typically, we're going to look at, you might look at the standard deviation being somewhat close to 1. You may also look at the skewness and kurtosis statistics divided by their standard error, ensuring that they're not above or below 1.96, which is kind of the standard kind of test for that. So you could certainly do that. You can certainly look at these moments and confirm that they're within an acceptable range. But then also, again, as I pointed out before, the software will calculate these two tests, the KS test and the Shapiro-Wilk test. Shapiro-Wilk test, again, is the one that you'd want to report. It indicates, again, you're looking at 0.05 or higher on here. Okay, so this is a reverse of what you would normally do on a significance test. Typically, on significance testing, we look at some alpha and below. And the alpha oftentimes is 0.05 or 0.001 or something like that. So this is the reverse, though. Just don't forget that. This is, just write it down. Make sure you're interpreting this correctly. And again, this data, these are all kind of silly. These are all non-normally distributed. I did pull up earlier the HBAT data set. So you have access to this, and this is what's used in the textbook. So practice all of this if you want. But we can do the same thing here. Explore, got all this data. I've got all this data in the HBAT. So this is the textbook data. We have normality tests and histograms. So just to show you that it doesn't always have to be bad. I'll just pull up this data. There we go. So again, this is the HBAT data, just so you can see another data set. And we're looking at normality. Again, you can look at the skewness and kurtosis, divide the statistic by the standard error. We're looking at either plus or minus within the range of 1.96 plus or minus. Standard deviations close to somewhere around 1. But then if we pull down here, tests of normality, you'll see that some of these X6 and X7 are not normally distributed, but it would appear as though X8 and X9 is. X10 is above 0.05, so it is. X11 is, and so on and so forth. So this is a better example if you just want to see kind of a smattering of these normality tests and how, and then of course you can pull down and you can kind of visually just look at these histograms. And so that was not normally distributed, nor was the next one, but I think the following one. So this one just, it's got this skewness going on here. So that might be something that's really causing it to act poorly. And then this one here, if these guys were up, they'd be pretty good, but it measured as normally distributed. So according to the Shapiro-Wilks test anyways, it was in good shape. Okay, so so anyways, so that's what we do. So we look at normality, we assess the data, we describe the data, we look for outliers, we look for missing data, and we decide how to deal with missing data. And that's more or less chapter 2. I told you it was packed with a lot of stuff. It really is. It's not a light chapter by any means. And it's all part of the data prep type stuff. Okay, do you guys have any questions? You guys good so far? All right, so what I want to do, and that's kind of, you know, the way I do this typically, again, is I try to spend a good portion of time walking through what we did or your homework, just as a review, answering questions, those types of things. Then I typically try to give a preview of the next week. So we're into factor analysis week. Again, there's plenty of resources for you to practice and to work these examples. And obviously there's a homework assignment too. So that's available as well. So I want to talk a little bit about factor analysis. And I did just also want to, assignments, yeah, factor analysis assignment. All right, so this will use the fossil survey data. So there's a couple, there's a survey, and then there's the data set for fossil watches. And then what you'll do is a factor analysis. So let me walk through the basics on factor analysis. This is the first multivariate technique that you'll see this semester. And again, a variate is a series of weighted observations. It's basically what it is. We're looking at a series of weighted observations. And imagine that you've got several series that you're looking at simultaneously. So it's if you can picture not one multiple regression, but say 5 multiple regressions happening simultaneously, that'd be kind of what you're looking at when you're doing a multivariate thing. So factor analysis is helpful when you're grouping variables. You're not it's typically not used if you're going to group respondents. We'll do something else for that. But it's a good start. It's a good beginning a technique. And again, it's used for grouping variables. So earlier I mentioned this idea of grouping together some of these variables that likely go together. So these CBT, well, that should be CBT, not CNT. It should be these CB, like these things all measure compulsive buying tendency. So statistically, you would think that these questions sort of go together statistically. And if they do go together statistically, we could maybe use them together as one variable. But I don't know that now. I'm not certain of that. It's something that I need to assess and I need to determine. So factor analysis takes your data and it combines variables, or it pulls together variables that behave similar to each other. And it gives you an idea that you're using, like, these psychometric properties of these questions share variance together and they go together. So like the idea of some of these variables, satisfaction's a good one. There are lots and lots of ways to express satisfaction. You can't just ask somebody, oh, are you satisfied? Because they could interpret that in a lot of different ways. And so what we do is we devise questions that ask satisfaction a number of different ways, because each question hits on a little bit of a different part of satisfaction. So combine all the questions together, you get one composite of satisfaction, but it takes all those questions to do it. So factor analysis then allows us to take variables, put them all together in one big pot, and then the software separates them out with variables that go together. All right, so that's kind of the way this works. Now again, I've labeled a lot of these, so these should kind of break out together. This emotional attachment if I remember correctly, emotional attachment actually had a couple dimensions. So it may act a little squirrely. We'll just have to look and see. But otherwise, we take the scale variables, and what we're looking to do is throw them in the big pot, shake it up a little bit, and see what comes out. So to do this, and again, there are videos on this. Tonight, I'm not going through all the minutia and all the details of it because there are videos on this, and the textbook goes into great detail. And so you'll be able to do all this. You just follow along. And we'll, again, Monday next week, we'll go over the homework assignment and walk through it and all of that. But basically what we're going to do is we're going to go to Analyze, and we'll go to Dimension Reduction. So think about this. If we have like 30 variables, and those 30 variables can be consolidated onto, say, 5 like factors or themes. It's kind of like a theme in qualitative work. If those 30 can be loaded onto 5 factors, then I'm in essence reducing my data from 30 data points to 5, right? So it's data reduction. That's kind of the idea of it. Go to factor analysis. And let's see here. Okay, so this is one thing I don't like about SPSS. It gives me these questions. All right, so let's just do a few of these though. Let's not do all of these necessarily. In fact, let's take out, just for now, I'm going to take out the emotional attachment ones. So basically I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, about 11 or 12 or so questions, something like that. Identity signaling is 4 of them. Social recognition is 4 of them. And then esteem is 3 of them. So just because I created the survey, I am intentionally trying to measure 3 constructs that are not directly observable, but I have to ask several questions for. And so I use these 11 or 12 questions to measure these 3 things. So now I want to see if that in fact is the case and that these items hold together the way I expect them to. Okay, so I'm going to specify a few things here. I'm going to specify the anti-image matrix and the KMO in Bartlett's test for I can't say it, I'm tongue-tied. Those guys, all right, for now. And there may be some other things to do later, but we're not going to worry about those exactly tonight. A scree plot is something that you should get in the habit of looking at. So we're just going to check that. We're going to keep this the way it is just for now. And again, you're going to learn more about that this week. Here, you need to check one of these. Varimax is the default selection. So you can choose Varimax or you can choose Promax or any of these others. But Varimax and Promax are the 2 most common. And again, you'll learn more about these here this week in a little bit more detail. There are some nuances there that are special. Not going to really worry about save as variables right now, but that's something that we would do later on. And then options. Here's an imputation method. So replace with mean or exclude cases list-wise. So again, if I'm foggy on this, I'll double check, but you would be replacing or removing variables if we did that. Pairwise, we'd be removing individual responses, which you lose less data if you do that. Or you could replace with mean. So if there's an empty spot, it just means that that empty spot will be replaced by the variable's mean, and that's an imputation. It's like a missing way we deal with missing data. Okay, the other thing that I'm going to do is I'm going to click this sort by size, just because you'll see it'll be easier for us to read the thing. And again, you'll practice this. You'll have fun with this week. Trust me. All right, we're going to okay it, and then we're going to see what kicks out. Again, we're looking for 3 different variables. What's happening here? Okay. Oh, that was weird. It just dropped me down. Okay. So the KMO Bartlett's test. So what we do is we want to make sure the data is appropriate for this type of analysis. So like the idea is variables that go together need to covary with each other, and variables that don't go with each other don't need to covary with each other. So it's kind of like we're looking for patterns to make sure the variables are going to fall in with each other versus not. So here you want something above 0.7 in terms of what we're looking at for the KMO. So we have 0.892. So that suggests that the data is sufficient for this analysis. So above a 0.7 on the KMO, and you want something that is significant, so below 0.05 for the Bartlett's test of sphericity. Okay, so initially our data looks good for this type of analysis with the variables we chose. The other thing that we're going to look at, and again, I'm not going to go into huge detail tonight, but we look at the diagonal scores on the anti-image correlation matrix. So again, you're going to go through this. You'll see this over and over again. It needs to be ideally above a 0.7. So we have a 0.9. This is like 0.9, 0.8. That's a 0.8 something there. So all of these all the way down, 0.8, 0.8, 0.9. These are all super good. So those are all super good numbers. Those are the things that you want to see. So that suggests that the data that we've chosen is appropriate for analysis. We're going to drop down a few of these things. Okay, so this is interesting. Typically what we do is we look at a chart like this, and we're looking at total percentage of variance extracted. And when we're looking at these numbers, there's a benchmark or a rule of thumb that you want something greater than 0.1, than 1, greater than 1. So it looks here like there are two factors that are loading together with these variables. Now, remember, we wanted 3, so that's why that's interesting. This is just a typical, this plots these eigenvalues up ahead, up above here. So this plots, so we had the 5.7 and then the 1. And what we do is we look at a break point where this goes flat. So this is kind of after 2, it flattens out. So 2 is kind of the visual of this chart up here. And then we're going to slide down here to the pattern matrix. And this is really where the rubber meets the road. This is what you want to look at. So what this suggests is that there are 2 factors, and these are the questions on factor 1 that go together. And what we want to do is we want to look at the value or the size of these. So we have 0.9, 0.89, 0.81, 0.74, 0.69, 0.56, 0.56, and then it goes drastically low or negative, and we slide over to factor 2 where it says 0.9, 0.8, 0.7, 0.5, and so on like that. So what you're looking for are high numbers that sort of group together, and once they start to break, then it means you're moving over to the next factor. So these items, it suggests, go together, whereas these last 4 items, the data suggests go together. Now, this takes a lot of interpretation. This is not an easy thing to do right away, because as a researcher, like if you've got a data set, like I know these questions and I know the way I asked them and what I wanted to have happen. But for whatever reason, the data is not kicking out the way I expected it. So I expected 3 factors, and here there are just 2 factors. Now, the interpretation part comes in this. When you look at those factor loadings, the 0.927, 0.893, 0.814, and so forth, when you look at those, what you're looking for is a dramatic drop. And quite frankly, I almost never keep anything below like a 0.7 or 0.6. So when I look at this, I'd probably keep this 0.692, maybe. But these other two that are in the fives, those are uncharacteristically low for the others in this group. And same with this very last one, the brand makes me stand out from the crowd. Uncharacteristically low from these others that are in that group. So this kind of tells me that there's something else going on with the data. So as a researcher, number one, I planned on 3 factors. I intended to measure 3. Number two, the data isn't very clear. That it's not consistent in my experience. So now as a researcher, what I do is I go back and I try a few different things. So factor analysis, you're going to find with your homework assignment, is trial and error. It's a little bit of back and forth. It's kind of like if you're doing a regression and you try different variables and then you run a few more models and you add some variables and you lose some variables and you sort of work through a process to where you find a good solution. It's kind of like that. It's not like cut and dry. You've got to kind of make some managerial decisions here on what you're going to do. So with me, this is clear. It's clear to me that 2 isn't sufficient. So what I'm going to do is I'm going to go back to the data, back to the analysis, and there was a tab over here called extraction. And again, I know I went through it quickly. We had this thing that was extract, and this is like extract the number of factors. And this was that have eigenvalues greater than 1. So if you remember that scree plot and that chart that had 2 factors that were higher than 1, that's where this comes into play. It only gave me 2 solutions, 2 factors, because only 2 of them had eigenvalues greater than 1. I'm going to change this. I'm going to ask it to actually do 3 factors, because I think there should be 3. And the data is not conclusive with 2. And, well, I just think it should be. And we're going to try it and see what happens. That's the beauty of data analysis. You can just work it until it cries. And it usually does one way or another. So we'll try it. I'm going to continue, hit OK. Get the same data. The measures are still fine. The variables are still adequate for analysis. We won't talk about communalities today. And this all remains the same. None of this changes in terms of the chart and all that. But what will, you'll notice there are 3 components here, or 3 factors now. And these are going to change a little bit. So we have the brand. This brand would help introduce me to others. This brand would help me become noticed. This would help me become recognized. The brand would help me become appreciated by others. These variables are positive. Again, that 0.655, maybe that's a little low, but it's not that far away from 0.757. And okay, it's clearly there's a big drop after it in this analysis. There's this 4.82. So that's kind of interesting because it kind of suggests that this item may, what we say is cross-load. It may load on number 1 and it may also load on number 3. So that's an interesting one in and of itself. Second component here starts with the brand elevates my sense of pride. The brand enhances my sense of self-respect. And the brand enhances my sense of confidence. Those seem very reasonable, as if they go together. And again, once we hit that point, it drops off. And then the last factor, this brand showcases my identity, it's my personality, and then it displays the social status I desire. Those go together. But then we got, again, this oddball one. This brand makes me stand out from the crowd. All right, so here's another like kind of part of this. I've got to, again, kind of think about the data. the numbers do not support, like what you don't want to have is one item that measures two things at the same time. That's messy, and it creates interfactor problems. You really don't want that. So now as a researcher, I'm like, okay, well, look, I'm going to try and run this again without this item and just see what happens, because it makes sense that this item shouldn't be here to me. So this brand makes me stand out from the crowd. I'm going to eliminate that from this analysis. I'm going to rerun the data. Makes me stand out from the crowd. Oh, wow, look at that. First one. This brand makes me stand out from the crowd. Okay, I'm going to take that out of the analysis. All right, and let's rerun it without that one. So I lost one variable. That's okay. I'm going to rerun it. Okay, so, but now that I changed the variables, I do need to double check. My KMO is still good. Bartlett's is still significant. These anti-image diagonals are still going to be, those are going to be good. I could look at those, but I know they're going to be fine. Then I'm going to drop down here. I still only have 2 factors indicated, but I've already kind of moved past that a little bit. And now I've got these, so I've got a 4-item scale here. It would help introduce me to others, help me become noticed, help me become recognized, and help me be appreciated by others. Then we have, it elevates my sense of pride, enhances my sense of confidence, enhances my sense of self-respect. And then finally, it showcases my identity, portrays my personality, and then it displays the social status I desire. So those then are my reduced scales. And that's probably what I'm going to go with, you know. And that's, you know, and again, I only looked at 3 kind of sets of variables. This data set has a lot more, and you can run them all simultaneously, but it's a challenge sometimes to do that. And that's what we're doing. Now, mentioned earlier, one of the features of this, well, I'll tell you what, before we do that, one of the things you're going to do as part of the assignment or as part of the analysis is you're going to test for reliability. So that'll be the next thing that you probably do. I guess we won't really go into that right now tonight, because you'll look at that and it's easy to do. You go into to analyze, and then under reliability analysis, we calculate something called we get the alpha here, which is not the same alpha in significance testing. It's the Cronbach's alpha is what we measure here. But basically, we could look at this like this first factor helps me introduce me to others. It helped me become, I don't know what one that is. That one, become appreciated, become recognized, noticed, appreciated, noticed, introduce me to others, recognized. That's the one that I'm missing. We do that. And then we do okay, and we have a Cronbach's alpha of 0.872. You need something above 0.7, so that's perfect. That's good. So this is a good scale. This is fantastic. You know, each of these scales are going to be good. We did reliability, and there are a couple other ways to do reliability as well, but that's what we want to do. Last thing I'll show you, just as a side here, we did factor analysis. Scores we could save as a variable, and we'll do it using a method called a regression method. And so what we do is we do continue. We talk about composite scores. This is going to create a composite score for each of each respondent, for each of those three factors. So don't get thrown off by the negatives right now. We'll talk about those at a different time. But these are basically composite scores. They're standardized, so you're going to have some below 0 and some above 0. And the average of these will be, the mean will be 0, and the standard deviation of each column will be 1, because it's standardized. It gives you a standardized answer. But these are the weighted scores for each of these factors for each respondent. So it's a composite score. So I just took all of those variables and reduced them to three variables now. So so that's kind of the way it goes. So factor analysis is actually one of my favorite things to do. I think there's only maybe a one or two like studies I've done where I didn't do factor analysis. It's actually used quite a bit. And it's a good introduction to multivariate analysis. If you, just kind of, as you think about these that are done here, each column here is like a variate. So each of these numbers here, the 0.936, the 0.804, and so forth, those are like, those are coefficients that were estimated for each specific factor. So again, dropping back and just saying, hey, what does multivariate mean? Well, each of these columns, 1, 2, and 3, is a variate, and each variate has been estimated for a very specific purpose. And so we have 3 variates that have been estimated simultaneously using the same data, but telling us something differently for each specific one. Okay, so it's this string of numbers in the column, that's the variate for factor 1. This is the variate for factor 2, and then the variate for factor 3. These are not betas. They're like, kind of, if they're analogous, I guess, to what a beta would be in a regression, but they're not a beta. It's a weight that's been estimated. So each of these techniques that we do in multivariate analysis has some type of a weight like this that's applied to the data in order to form the, in this case, the composite score that's ultimately used. All right, so I gave you guys, I mean, we went through a lot of stuff tonight.
Sorry, quick question, Dr. Flight.
Of course, don't be sorry.
Yeah, so the factor analysis, is this done like before? So when is this done? What stage?
Fantastic. All right, fantastic question, because it's a chicken and egg kind of an issue. So what happens is, what typically happens is, if it's new research, then you create these questions and you put it out into a pilot survey, collect data, and then run the analysis on the questions, and then refine the questions, and then do it again, and maybe do it a couple times, so that the scale becomes confirmed. So this is actually called exploratory factor analysis, EFA, and it's just kind of something that is done. Again, this is another example of where, if you have a large enough sample, you can do a like a holdout, and you can do exploratory factor analysis on some of your data, and then use the rest of your data for final analysis. That's a little bit of kind of like a magician's trick, to be honest. But scale development is actually really, really time consuming, and it takes several iterations where you're collecting data maybe 4, 5, 6 times to get the scales correct. Now, fortunately, a lot of this work has already been done. So these questions that were used in this survey have already been used in other research. And so there's data that's already available that tells us that these are good questions to ask and that they should kind of go together. So if you use data, like if you use questions that have already been used in the past, then instead of exploratory factor analysis, you're really kind of doing something called confirmatory factor analysis, sort of. I mean, not in a technical sense, but you kind of are. So like right now with this data, I'm not running this analysis because I think the questions are suspect or I think the questions are inadequate. What I'm running it for is to more or less confirm that my sample behaved the way most samples behave with these questions. So the fact that I lose it, like I dropped a question here. So I dropped a question out of the original set. That's not ideal, but it's probably more of a reflection that that this sample, it just didn't like behave psychometrically the way other samples have. So it's not like the end of the world. And trust me, if it's like brand new scale work, again, it's really time consuming and you have to do a lot of different data collections. But if you've used these questions before, or you've seen these questions used in other research, then you can feel pretty confident that they'll behave the same for you as they have in the past. And so again, I kind of know what to expect because I know these questions have been used, but I need to confirm that they are measuring what I want to measure and that they are behaving together the way they should. So your question's certainly fantastic. You know, again, you do the survey with the best questions that you have. As soon as the survey is done, this is the very first thing. I always do this analysis first before I do any regression, before I describe my data, of course. I make sure there are no anomalies in it, but then I jump right in and I just make sure that my measures are measuring what I want them to measure. Because that's like kind of like a validity issue. You want to make sure that what you asked actually measures what you intend to measure. And then you do your analysis after that, like you do whatever testing you're going to do after that. Yeah, fantastic question.
All right, thank you.
Good. All right, so where are we? So we talked about the homework assignment, and I know I dragged on that quite a bit in terms of like the different steps for evaluating your data. I talked to preview with factor analysis, just kind of walked through a brief example with that. We talked about this week coming up with the discussion question. That's going to be due, remember the last time to post, it's due Saturday at midnight. So, there's a good amount, there are a lot of videos. I hope the videos are beneficial to you. I have not yet looked to see how many have been viewed recently, but I encourage you to look at those. They correspond with the text. They correspond with the data analysis. If for whatever reason you want to like watch other videos or whatever on factor analysis, I guarantee you there's thousands of them out there. Factor analysis is it's like regression. It's a very common technique. So there's no doubt you can find plenty of resources to help you just as examples. Let's see, other than that, do you guys have questions or things that are you're concerned about or that you're happy about or anything that you want to talk about? No? Okay. Well, because that's about where I am. I mean, that's my list of things. Looking at next week. Oh, we're doing We're doing mediators and moderators next week. Okay. We'll review factor analysis, which will take a little, we won't, it'll take probably an hour, hour and a half. But then we'll do regression, and we're also going to spend a good amount. Is that right? Yeah, we're going to spend a good amount of time on mediators and moderators, which is a good topic to talk about. It's a little bit different and it's just a series of regressions, but it's model building actually that becomes fairly important, and can be a little complicated, but it's okay. So that'll be it for next week, though. This week, we're all on factor analysis. All right, so any other questions? Anything we should talk about for the good of the cause? You guys having fun? Okay, I'm hoping that the weather turns really, really rainy and nasty, so all you have to do is, can't do anything outside, stay inside, stay with your computer. But seriously, let me know if you have any questions. Obviously, the earlier in the week probably, is good. If you wait till Saturday and Sunday, I'm not quite as available, but I'll do my best. I will absolutely do my best to get to your questions and such. But anyways, yeah, please let me know if you have questions. Okay. All right. With that, I'll let you go. Have a good night.
You too. Thank you.
You're welcome.
you.
Happy to
Bye.
see
Thank
you.
you.
Good seeing you. All right.